calculate this, for example, say, let me make one example, say -1 plus j. Okay, for this one, if you want to calculate its phase, and usually you do is from what we did is here is the imaginary part divided by the real part, which means it's arctangent, and 1 divided by -1, right? So whatever the number is, so I think you're going to punch your calculator or using MATLAB. And if you do that one, that will give you is -45 degrees. Okay, but in terms of our complex functions, so here is a real axis, imaginary axis, and that one, this point is here. The phase angle we define, so this is this point, okay? The phase angle here we define is 135 degrees. Okay, so that means here, that is the thing. You have to manually convert this number from -45 to here. This is the only thing, and this is the critical part you have to take care in all of your calculation in this chapter in root locus. The reason why is this: in trigonometry, this is tangent, this is x. So this is 90 degrees, and this is the minus and the minus 90 degrees. So this range, this is the domain, the trigonometry taken on for calculations. And however, for our in the complex plane, by definition of the phase angles, for some reasons, that one basically defined, for example, from 0 to 180 or from 0 to -180. So either in our the complex plane, this is our domain, either go here, okay, or go minus, go the other side. So basically, that is the meaning. The domain of the two functions, they are different. Okay, so that's the reason why. So anyhow, for whatever this one, the MATLAB or your calculator give you is this number here. Okay, so here in our complex plane, we define the angle measurement. This is positive, and this is negative. Okay, so for this calculator, that will give you is this number. Okay. Yes.
Why wouldn't it go into the fourth quadrant in the bottom right, like down from the positive right?
Yes, you can also go from here.
Well, why? If it's a negative 45 degrees, don't you usually measure the 45 degrees from the positive axis of the graph?
Say that again. I didn't get it. 45. Why 45 degrees?
So
You usually start at x equals 0, like
the positive axis. So wouldn't it go down this way? I don't know. It's just like a clarification question.
No. For this number, okay, we fix this one first. So basically here, what we need is we measure the angle from the real axis and follow this time convention. So by all means, this is the 335. That is the one you have to take. All the other numbers, that will make you a wrong result. Okay, and that will give you the wrong result in determining the phase angle. Okay, so that's the first one. The second one I can tell you is this -45 degrees, and this one can be achieved by in terms of the calculations. So basically that is the -1, right? So here we have a few possibilities: arctangents of -1, and arctangents 1, -1. For this one, you can see this is the in complex plane. We have the axis is -1 here.
Oh, I see. Okay. Okay, I see.
So that is a point here, and for this one, that is the point in the complex plane. Is 1 -1 is here.
Okay, yeah, I see. Thank you.
Okay. So that is kind of the very tricky thing. And for this case, of course, if we're using, then this is our angle here. So this one is, for this one, the phase angle is is minus 45. That is what we need. So for this point, if the point is here, then your calculator will likely you will get the right number. But if the point is here, then you have to convert. Okay, so you have to know what you are doing. And basically, the best way I would recommend is this. For whatever the point, you're going to calculate their phase on the complex plane. Then you simply label, for example, the point is here. Okay, so from here you know, okay, for this point, the phase must be more than 90 degrees. 90 degrees plus something. And then that something you should be easily tell from your calculators. Okay, either, yeah, so that is the one I mentioned to you. And this one will be helpful for you to complete the last questions, the problem 4. And in this homework 5, I put into 2 parts on Blackboard. The first part is for question 1 and 3, or question 1 to 3, and taking up your numbers and calculation numbers, so you have unlimited attempts until you get the right one. And the second part is for question 4, and that is our last question. The question 4 is a multiple answers question. So basically, A, B, C, D, E, F, 6 options for you to choose from. And then the correct solution, they should have contained correct, 3 correct answers. So from A, B, C, D, E, F, you need to pick 3, and that should be the right answer. And for this one, you only have 2 attempts. If you miss them all, then you have no point. If you shoot one correct, you will get partial credit. So basically, for this question, yeah, these are partial credits, and this one, the last question we're going to use, simply ask you to calculate the phase angle, and using phase angle to justify whether one point is on the root loci or not. If a point is on the root loci, then basically you have to satisfy the phase angle criteria, and that is 180 degrees plus some module of the 2 pi, right? So once you have time to read through the detail, you will know what I mean. So here I give you for the first, the last question 4. Basically, I give you 1 characteristic equations. Okay, and that equation, for example, here is 1 plus k, s plus 10, s plus 5 equal to 0. Then I give you A is 1 point is something, B 1 point is another one. And I'm asking you how many 3 of the points are on the root loci. You need to pick 3. And how can you verify? You simply, for every single point, you apply the phase angle criteria to this one. So basically, the phase angle criteria for this one is this. You know, because s plus 10, s plus 5, let me rewrite. So this one is equal to minus 1 over k, right? So here we have the magnitude criteria. That means s plus 10 and s plus 5 equal to minus 1. So here in my assignment, the k is positive number. Okay, so here is 1 over k. For the phase criteria we have is the s plus 10 minus s plus 5 equal to 180 degrees plus 2L times 180. So L can be any integer numbers, minus 2, minus 1, any integer. Okay. So for this question, if you want to see whether the point is on the root loci, you simply use this. You simply check using the phase criteria to check. So that means, for example, here the 1 is s minus equal to 6. Okay. So that means what you do is you simply plug in s equal to 6. Minus 6, s plus 10 minus 6 minus 6 plus 5. You check out what is the phase angle here. What is the angle here? If this angle falling into, say, 180 degrees, minus 180 degrees or 540, whatever the number you fit in here, then that guarantees this is on the root loci. If this angle is not equal to this one, then the answer is no, right? Okay. So here, simply for this case, I design is simply ask you to practice 6 times of the calculating angles. Okay, so and because there's no time limit on this question, so I would say you just do it at one time, and then you should be easily identify the 3 and then pick one. Okay, pick that. But gradually, once we proceed our lectures to more systematic way, and you will gain more systematic approach to help you answer those questions. So we will see, gradually see. Okay, so now for this homework, my design, the essence of the design is assuming everyone have no idea how the systematic approach to draw the blue loci. We just based upon our information on intuition, on complex functions. We just based upon this, you should be able to complete all the questions. Okay, so that is the essence of this one. And to help you review the complex functions and help you to integrate that information with our topic, that is the homework 5. So that is the one, and then we can continue more lecture things. So here we spend 2 lecture hours, and we talk about we review the needed information from complex functions, and we gone through a few examples, and to see how can we utilize the basic mathematics to help us. So here I would like to give a few more examples here. And right now we are on our the textbook chapter 7, and pretty much chapter section 7.1, and here could be, if you really like to read textbook, this is about the content 7.2. Okay, so I know some of you are study very hard, and they even push me. Why not you haven't had new homework come up for us to practice? Okay, and therefore I've seen only your class starting from last year. That is for my first time in my teaching career. The students sent me email. Why not? When you have a new homework come up, and that is the first time. You never have students ask teachers, even for myself, when you have your homework ready. No. But in this class from last year, every single semester there are always students and push me. And when you have your next homework ready, and then I want to do it. Okay. So that's the one, that's the story behind this. Otherwise, for homework 5, I would say postpone to sometime next week, so we have more information. But anyhow, okay. So here, let me consider a few more rigorous examples here. So here, if we consider diagrams, so this one is the higher order, a little bit higher, the 3rd order systems. Okay, so here quickly, you know the transfer function is y over r. You should be able to derive it, and then you say this defined, this is gs. Okay, so the transfer function is g1 plus g. So therefore, the characteristic equation simply is 1 plus g equal to 0. So that means 1 plus k as plus 1 as plus 2 equal to 0. So definitely, this is the 3rd order system, and before today we practice is at most a 2nd order system. So from here we rewrite this equation. This is our standard form, and now we want to look for all the points satisfy this equation for all the value of k. And here I think for this one, for these chapters, if not otherwise specified, here is our intrinsic assumptions. for most of the root loci problem, we always assume K is the non-negative value, because if you can do this range, then you simply flip turn. You can cover the root loci for K less than 0. So otherwise, if no specific assumptions, then you simply take out this is the default assumption, K is positive. Okay, that is a very common practice in root loci number control. So here, if we want to solve for the roots of this one, and again, let me rewrite. So here is s plus 1, s plus 2, 1 equal to minus 1 over k. So from these is equations, we put into the magnitude criteria, and which means 1, the magnitude of s, magnitude of this one, and magnitude of this one equal to this. And because k here we assume is positive, so that is this one. And the phase angle criteria is this 0 minus the phase of numerator minus the phase of s minus the phase of s plus 1 minus phase of s plus 2 equal to 180 degrees plus 2L times 180. Okay. So now with those informations and all the we start from here. That is the only two equations we can use to develop to find the roots. And again, our goal find its roots for all k. Okay. So with these equations, we're going to find all the roots and for any kind of a number of k. So we can give a try. So you can see from the characteristic equations, and we rewrite into this. So you can see on the left-hand side of this actually is our G. Okay, so in textbook, basically this is our GS. Okay. So you don't need to memorize this, basically because that is the very natural derivations from here. And GS in textbook, in many textbooks, then it's called the, sometimes I refer GS as the open loop transfer functions. And, okay. And sometimes, and in particular in our textbook, it's referred as loop transfer functions. Okay, and people have a little bit different kind of the invention of the terminologies. But in our textbook, it's using this one called the loop transfer functions. Okay, so from here we pick out the loop transfer function, and now we can draw. We can see how can we draw it. This drawing, pretty much, I would say you can leave about half page your notes for this drawing, because quite a few notes will be made on this drawing. So before we make our attempts, the first step is we label a few specific points, and from here, and upon the loop functions, here the step one is based upon the loop transfer functions GS. It has 3 poles at 0, -1, and -2. Okay, so that is a specific information inherited from the province. So we label whatever we are given. So here we use the poles, we use the cross mark to indicate locations of the 3 poles here. So this is 0, this is -1, this is -2. So now we have this one, then again we can follow up our strategy as we did last time. We're looking for all the possible routes. So the first try is I'm going to try the routes, the possible routes on the real axis. And once I fix this one, then I will develop into other 4 quadrants. Okay. So here again we pick any point here. Okay. And say, for example, the point is here, then we can give a scratch, certain scratch calculations. So that means I hope you will have make enough space for your note taken. So here is on the other side, we can take one. So our try is, first one we take the test point here. Okay, so here is a test point, so let me call this whatever here. So from here you can see for this test point, so that is, again, this is our scratch calculation. Here is the 3 nodes here. Okay, so from our test, so this is our test point. So again, right now I'm going to use the first criteria here. Okay, for the first criteria we can measure is 1 minus s minus s plus 1 minus s plus 2. So for this point we have is this one. So this is equal to 0, right? And then what is this? This representing is the you know what I mean. So basically this is okay. So here is the complex plane. So say if here is our test point, if here is the our say whatever our original say minus 1 minus 2j. Okay. So the difference, the phase angle between the two, basically what you did is this. You start from here. So say this is s equal to a. So s minus a, the phase angle is simply is this. You take a as the origin, you shoot an arrow pointing to there, and the angle from here measured is the phase angle. Okay, so from here you can see this arrow is like this, and this one for this case is 0. Okay, and then the second one, this is minus 1. So this number is, we simply take the arrow from here to here. So again, you can quickly see this angle is 0 degrees. Okay, and the last one, the same thing, is 0 degrees. So again, if we pick up the test point here, then the phase angle is 0 degrees. Doesn't meet. So all the points to the right of this won't fit. So we kick out one segment. So now we move to our focus to here. So we take any test point in between 0 and minus 1. We try again. Okay, so now we take our test point here. So we repeat it. So this one basically is, the vector is like this, right? So here for this one, this representing is s. So here we measure is 180 degrees. So here is minus 180 degrees, right? And now go to this one. So now this one basically is this arrow, this vector here.
0.
Okay, so this one is 0 degrees. And in the similar way, is 0 degrees. Okay, so from here you can see for this value is minus 180. So this result fit into here. When we take L equal to -1, that's a minus 180. So which means any point in between this segment will make up the root. Okay? And now we move on. So keep trying. So now we move to here. Okay, so now you can, I believe you can quickly do the calculations.
-360.
So here now the point is here. Okay, so the first one, this angle is, we simply take is the arrow from here, right? So this is 180 degrees. For this one,
180.
yeah, that one is, let me use the colors. Yeah, this one is from here to here, right?
Mm-hmm.
Okay, so this one is again 180 degrees. And the last one is to 2, so that one is from here to here.
0.
So that is 0 degrees. Okay? Okay, so that means the result is 360 doesn't fit. We're asking is 180, 540, minus 180, or etc. So this one gives us 300, minus 360 doesn't fit. So that means anything in between here, no good. Okay, now we move to this one. So now our test point is here. So now this is the first one. Okay, so the base angle between S and 0, so that is this one. So that is 180 degrees.
180.
And minus, and then this angle, this test point to -1 here. So this one is 180 degrees. Okay, in a similar way, this angle to -2, S plus 2, so that again, this is 180 degrees. Okay, so this check. So that means we have here. This is go to infinity. Okay, so go to infinity. So now we fix the root locus on the real axis. And these rules will be true for all kinds of situations. So from here, you can pretty much, well, later we can